OnlyZeroCarbon.org presents the science of global warming and climate change. In this video we're going to be looking at the properties, the behavior of greenhouse gases when they're in the atmosphere. We're going to be looking at them at the molecular level and then actually at the atomic level, because that's what determines that. Here's carbon dioxide, here's methane, and here's nitrous oxide. Now it's very important that we get something fairly obvious clear in our heads, and that is that when they're being emitted, and they're being constantly emitted, they don't just vanish into thin air, they stay up in the atmosphere. All the molecules of these gases, when they're emitted, they stay up in the atmosphere a long time. Methane, which is a powerful greenhouse gas, stays the least period of time, but that's 12 years. So if just think of each methane molecule being added to the atmosphere, each one lasts for 12 years before it disappears. Carbon dioxide lasts a mean of about 100 years, so each molecule is going up there and it's lasting 100 years before it goes. And nitrous oxide, which is far more powerful as a global warming gas than carbon dioxide or methane, that lasts in the atmosphere a little over 100 years. So it's obvious that these greenhouse gases, then all the time they're being emitted, they're going to accumulate in the atmosphere. Their concentration has to increase. And that's a very straightforward thing to understand, and it's fundamental to understanding global warming. This illustration shows the heat-radiating greenhouse agents that are present in the lower atmosphere. First, water vapor. Water vapor is the top heat radiator in the atmosphere. It is present in very large quantities. It is also very important to global warming and climate change because it exerts a strong positive feedback to global warming caused by the other emissions. Carbon dioxide, methane, and nitrous oxide are the top heat-radiating greenhouse emissions. Although every single one of the emissions is crucially important, they all share the same property of heat radiation to the lower atmosphere and to the surface of the planet. We'll take a closer look at this most basic climate change science by focusing in on carbon dioxide in the atmosphere and using carbon dioxide as an example of any of the other greenhouse gases. This can represent one or any number of carbon dioxide molecules in the atmosphere, here the lower atmosphere. The surface of the planet receives energy from the sun in the form of short wavelength light energy that passes straight through the atmosphere without disturbing the greenhouse gases in any way. At the surface of the planet, the light energy becomes infrared heat energy, which is radiated from the planet's surface up through the atmosphere. When this infrared reaches a greenhouse gas molecule in the atmosphere, it energizes the greenhouse gas molecule, which then radiates heat in all directions. The lower atmosphere is warmed by the radiating heat from the greenhouse gas molecule, and that warms the planet's surface. Here is an animation of the final picture. And here with more greenhouse gases added. The more greenhouse gases are added to the atmosphere by greenhouse gas polluting emissions, the more will be the heat radiated by them in the atmosphere, and the more the heating of the surface of the planet, and that is global warming. We now go to the very basis, which is the absolute proof of the reality of global warming, by looking at the level of one molecule of greenhouse gas in the atmosphere and its atomic structure. The atomic structure of the greenhouse gas molecule determines everything about the greenhouse effect and about the reality, the absolute reality of global warming. Here is one molecule of carbon dioxide, CO2, one atom of carbon, two atoms of oxygen. It is this atomic structure which determines that a greenhouse gas in the atmosphere is an absorber of infrared heat energy, which energizes it, and thereby the greenhouse gas molecule emits infrared heat energy as long as it is in the atmosphere. Also determines that the more greenhouse gases are added to the atmosphere, the more heat will be radiated within the atmosphere and to the surface of the planet, and this is global warming. This animation demonstrates how the greenhouse gas molecule is energized and emits infrared heat energy. It actually vibrates with the energy. Crucial fact, these heat radiating greenhouse gas emissions are constant. There are three gases that are long-lasting in the atmosphere. These three gases are also being emitted constantly in substantial amounts. They are carbon dioxide, methane, and nitrous oxide. Such long-lasting greenhouse gases must accumulate. They must continually build up in the atmosphere for so long as they are being emitted, and they most certainly are. If we regard the atmosphere as a huge bowl, and greenhouse gases are constantly being poured into this bowl because the tap is always on, this explains accumulation. Carbon dioxide is unique and much more than a long-lasting greenhouse gas. It is in fact an ultra-long-lasting greenhouse gas in the atmosphere. 20% of carbon dioxide emissions last 1,000 years in the atmosphere. So as carbon dioxide accumulates in the atmosphere and its atmospheric concentration increases, the substantial amount of carbon dioxide that lasts in the atmosphere for 1,000 years also accumulates. This extreme ultra-long lifetime of a substantial amount of all carbon dioxide emissions makes emitting carbon dioxide catastrophically dangerous. This is the reason why only zero carbon emissions can possibly lead to atmospheric carbon dioxide concentration falling or stop it increasing completely.